During the Cold War, the United States Navy spent decades listening for Soviet submarines, using a classified network of deep-sea microphones. In 1992, they let biologists look at the data and realized they had made a massive mistake. The Navy hadn't just been tracking submarines. They had accidentally been tracking the real-time, global movements of the largest animals on Earth. Imagine being a gray whale named Varvara. You are swimming from Russia to Mexico and back, a round trip of almost 14,000 miles. You do this in just over 170 days. That is 80 miles a day, for half a year, without a single visual landmark. If you are a terrestrial animal, you use roads, mountains, and smells to figure out where you are. But a whale threw all of that away millions of years ago. The ocean they move through is dark, mostly featureless, and completely ruthless. Sunlight vanishes rapidly as you dive. If you go deep enough, visibility drops to absolute zero. Worse, the water never stops moving. Ocean currents are constantly trying to push you off your intended path. So how do you cross thousands of miles of black water without getting lost? The answer isn't a single magical sixth sense. It is a highly integrated, multisensory web of physics, organic chemistry, and environmental memory. Let's start with the dark. To navigate immediate threats and hunt in pitch black, toothed whales built a flashlight. But they don't use light, they use high-frequency sound. Because they don't have functional vocal cords, they generate clicks using specialized tissues in their nasal passages called phonic lips. But producing the sound isn't enough, they have to aim it. To do this, they push the sound through a bulbous structure on their forehead called a melon. Here is where it gets strange. That melon is an acoustic lens made of highly toxic, endogenously synthesized fats. It is packed with strange short-chain lipids like isovaleric acid, which are extremely poisonous to most mammals. The whale carefully arranges these fats in a perfect three-dimensional gradient because sound moves slower through the dense, branched fats in the center of the melon. The chemical topography of the whale's own head physically bends the sound waves. It collimates omnidirectional clicks into a tight, forward-facing beam. And when those clicks bounce off a target, the echo doesn't come back to an external ear. Cetaceans don't have them. Instead, the echo hits the whale's lower jaw. The hollow mandibular bones are filled with the exact same acoustic fats, acting as a waveguide that channels the vibration straight into the inner ear. But high-frequency clicks die out quickly. They are useless for crossing an ocean. Baleen whales. The giants, like blue and fin whales, do not have phonic lips or a melon. For a long time, we thought they sang using vocal cords just like we do. We were wrong. They evolved a massive U-shaped cartilage cylinder and a vibrating fat cushion in their throats. They recycle the air inside their bodies to generate massive low-frequency infrasound. This closed system lets them sing continuously without inhaling water or losing their buoyancy. And they aim those deep songs into a very specific layer of the ocean. It is called the SOFAR channel. Usually sitting roughly 3,000 to 5,000 feet down, it's a zone where dropping temperatures and rising water pressure create a perfectly balanced acoustic trap. Acoustic energy pumped into this channel refracts inward. The sound waves continuously bounce along the center axis, bending back before they can dissipate on the surface or hit the seafloor. Because of this natural pipeline, a whale's song can carry across an entire ocean basin with minimal energy loss. That is exactly what the Cold War Navy's secret microphones were picking up. The whales were using the ocean as a giant acoustic mirror. By passively listening to the low-frequency noise of waves hitting distant coastlines or the echoes of their own songs bouncing off deep-sea mountains, baleen whales construct a macro-scale acoustic map of the ocean floor. But acoustic imaging still isn't enough to keep a whale perfectly straight over thousands of miles. To do that, they have to read the planet itself. The seafloor is scarred with static magnetic anomalies. Cooling magma at mid-ocean ridges has created parallel hills and valleys of magnetic intensity that stretch across the deep. Whales follow these invisible magnetic linknations like highways. This is why perfectly healthy whales sometimes swim directly onto a beach and strand themselves. When these natural magnetic corridors run perpendicular to a coastline, creating a geographical dead end, the whales trust their magnetic map over their own eyes. They also check their compass against the sky. Satellite data shows baleen whales non-randomly inhabit areas where the local magnetic declination aligns perfectly with the Earth's 23.44-degree axial tilt. By referencing magnetic lines against the rise and set azimuths of the sunday, they build stable heliomagnetic coordinate trajectories. And that massive compass can be blinded by something happening millions of miles away. When a solar storm hits the Earth, gray whale strandings spike dramatically. Researchers realized it isn't because the Earth's magnetic field was physically displaced. It is because the solar storm generates massive amounts of atmospheric radio frequency noise. That noise acts like sensory static. It points to a wild biological reality. The whale's magnetic sensor probably isn't a chunk of iron buried in its brain. The vulnerability to radio frequency? Noise strongly suggests they rely on light-sensitive cryptochrome proteins in their eyes. They are likely navigating via a quantum radical pair mechanism. Even with a quantum compass, migrating alone is incredibly dangerous. Ocean currents will physically drag a solo animal off course. So, whales use the wisdom of the crowd. Because their calls stretch for hundreds of miles, a visually isolated whale is actually part of a massive, distributed acoustic herd. Mathematical modeling shows that if individuals share their intended swim headings, the group averages out everyone's tiny navigational errors. This is called the many wrongs principle. It allows the collective to slice through heavy currents that would be mathematically impossible for a solitary whale to survive. But modern shipping and seismic exploration have drastically raised the volume of the ocean. This anthropogenic noise pollution can shrink their communication space by up to 80%. We are actively masking their network, fracturing the herd, and making them blind. When they lose their way, they risk missing their entire food supply. Long-distance migrants base their routes on inherited environmental memory. They time their swims to perfectly match historical 10-year averages of plankton blooms and sea surface temperatures. Some populations just stop trying to cross the globe entirely. 70,000 years ago, the Arabian Sea humpback whale completely abandoned the standard polar migration. Instead, they remain in the warm, tropical waters of the northern Indian Ocean year-round. They survive purely on the intense coastal upwelling driven by the violent reversal of seasonal monsoon winds. Today, there are roughly 82 individuals left, and further south, off the coast of Sri Lanka, pygmy blue whales have done something similar. They stay local, hunting shrimp deep underwater, and singing a distinct three-part song. But for over a decade, scientists have watched the pitch of that song drop steadily. Between 2002 and 2013, the frequency of their specific call decreased from roughly 106 Hz down to 100. No one knows exactly why their voices are getting deeper. It could be changing ocean chemistry or rising population density, meaning they don't have to shout as loud. What we do know is that these non-migratory whales are forced to feed inside one of the busiest international shipping lanes on the planet. The solution is surprisingly simple. Modeling shows that shifting that shipping lane just 15 nautical miles to the south into deeper water would reduce fatal ship strikes by up to 95%. So the next time you picture the open ocean, stop seeing it as empty, featureless water. It is a vibrant, three-dimensional map. It is crossed with invisible magnetic highways, seasonal thermal pulses, and deep acoustic pipelines carrying the voices of giants. The animals moving through the dark are not drifting. They are reading a world we are only just beginning to understand. We just have to make sure we don't accidentally silence the map